High above us, far up in space, lots of man-made stars are going around. These are called satellites. These clever machines are super important for our world today. From finding our way around and talking to each other, to knowing what the weather will be like and making new discoveries, satellites have changed how we live, work, and explore. Imagine a world where you couldn't quickly call someone far away or know if it's going to rain. Today, these smart machines are quietly going around our Earth, changing our world in ways we don't even think about. Come with me as we learn the secrets of these space watchers. A satellite is simply anything that goes around a bigger thing because of gravity. Our moon, for example, is a natural satellite of Earth. But when we talk about satellites, we usually mean artificial satellites, things made by people and sent into space for a job. These amazing machines come in all shapes and sizes, each one built for a special task. Just like us, a satellite needs different parts to work. These parts are meticulously designed and assembled by engineers to ensure the satellite can perform its tasks efficiently in the harsh environment of space. Each part is important for the satellite to stay healthy in space and do its job. From the moment it is launched, every component must function perfectly to keep the satellite operational. Let's look closely at the main parts of these tech wonders. Understanding these components helps us appreciate the complexity and ingenuity behind satellite technology. First is the power source. Without power, a satellite would be just a piece of metal floating in space. Satellites need electricity to run their tools and talk to Earth. This electricity is crucial for all onboard systems, from communication to navigation. Big solar panels, like the ones some people have on their roofs, are used a lot. These panels are designed to capture as much sunlight as possible. They change sunlight into power. This conversion is essential for the satellite's long-term operation. Next, we have antennas. These are like the satellite's voice, sending and receiving messages to and from Earth. Without antennas, the satellite would be unable to communicate. The payload is the most important part of the satellite. It carries the instruments and tools needed for the satellite's specific mission. It has the special tools for its job. These tools vary depending on the satellite's purpose, whether it's for communication, weather monitoring, or scientific research. For example, a weather satellite might have cameras to look at the clouds, and a communication satellite would have things to send phone calls. Each payload is tailored to its mission. Finally, some satellites have little engines to move around in space and avoid bumping into space junk. These thrusters help the satellite maintain its correct orbit and avoid collisions. Sending a satellite into space is really hard and needs lots of planning. It's like throwing a ball really high. You have to be strong enough to fight against Earth's pull. The journey starts with a rocket, a powerful vehicle that carries the satellite past Earth's air. As the rocket goes up, it drops off empty parts to save fuel, like taking off your heavy coat when you get hot. Once the rocket is high enough and going fast enough, the satellite pops out. The satellite, now free, opens its solar panels and antennas, ready to start its work in space. Satellites don't just wander around in space. They follow special paths called orbits. These paths are carefully calculated to ensure that satellites can perform their specific tasks effectively. Without these orbits, satellites would drift aimlessly, unable to provide the crucial data and services we rely on. These orbits depend on what the satellite is doing and which part of Earth it needs to see. For instance, some satellites need to monitor weather patterns, while others might be used for communication or navigation. Each type of orbit offers unique advantages for these different purposes. Low Earth orbit, or LEO, is like the busiest street in space near Earth. It's a popular choice because satellites here are closer to the surface, making it easier to send and receive signals quickly. This orbit is crowded with satellites performing various tasks, from Earth observation to scientific research. Satellites in LEO are a few hundred kilometers high and go around Earth many times a day. This frequent circling allows them to cover different parts of the planet multiple times, providing up-to-date information and continuous coverage. This is good for satellites taking pictures of Earth because they're close enough to see things clearly. High-resolution images are crucial for mapping, environmental monitoring, and disaster response. helping us understand and protect our planet better. Geostationary orbit, or GEO, is much higher, about 36,000 kilometers high. This orbit is ideal for communication and weather satellites because it provides a constant view of the same area. Here, a satellite goes around Earth at the same speed as Earth spins, so it seems to stay in the same spot above the equator. This stationary position is perfect for monitoring weather systems and providing consistent communication signals. Polar orbits, as you can guess, take satellites over Earth's north and south poles so they can scan the whole planet like a barcode scanner. This orbit is particularly useful for Earth observation satellites that need to cover the entire globe, providing comprehensive data for climate studies and environmental monitoring. Imagine talking to your friend far, far away, but through space. That's basically how satellite communication works. We send signals from Earth to a satellite, and then it sends them back down to another place on Earth. Stations on Earth send radio signals to a satellite. The satellite catches these signals, makes them stronger, and sends them back to another station or straight to our phones. We don't always see it, but satellites are a big part of our everyday lives. They orbit high above us, silently working to make our lives easier and more connected. Finding our way is one thing satellites have changed completely. With GPS technology, we can navigate unfamiliar cities, find the quickest route to work, or even explore new hiking trails with confidence. GPS satellites tell our phones and cars where we are and what time it is so we don't get lost. They provide precise location data that helps us reach our destinations efficiently. From finding the nearest shop to ordering a taxi, GPS is everywhere. It's integrated into many apps and services we use daily, making our lives more convenient. Talking to each other is another thing satellites help with. They enable us to make phone calls, send messages, and even have video chats with people across the globe. Satellite TV sends shows from one place to homes all over the world. This technology allows us to watch live events, news, and entertainment from different countries. Satellite phones let us talk even in places with no phone towers. They are essential for communication in remote areas, during emergencies, and for adventure travelers. Weather satellites keep an eye on the sky, so we know if it will rain or if a big storm is coming. They provide crucial data for weather forecasts, helping us plan our days and stay safe. Other satellites take pictures of Earth, helping us during natural disasters and keeping track of how our planet is changing. They monitor environmental changes, track deforestation, and even help in disaster relief efforts. Satellites are great, but space is a tough place to live. One big problem is space junk. This junk is old satellites, used rocket parts, and bits and pieces from things crashing into each other. It flies around Earth super fast and can hit working satellites. Another problem is that space near Earth is getting crowded, especially LEO. With more satellites going up, there's a bigger chance of them crashing, which could cause big problems for everyone. Satellites also have to deal with very hot and cold temperatures, dangerous radiation, and no air to breathe. Even with these problems, clever engineers and scientists are always making satellite technology better. The future of satellites is really exciting. One cool idea is mega constellations, thousands of small satellites working together. These could give everyone in the world internet, even in really far-off places. Satellites are also getting smaller and smarter. Tiny CubeSats are like mini laboratories in space, doing experiments and taking pictures of Earth. Artificial intelligence, like in robots, will make satellites even more amazing. AI-powered satellites could take care of themselves, change plans if something goes wrong, and even do complicated tasks without any help from people on Earth. As we move further into the 21st century, satellites will become even more important in our lives.